This is the test review guide for Algebra 2, Unit 11, Statistics and Probability. So the first question is asking you to find the mean and standard deviation of the data set given here. And the first thing that you need to do, mean, median, and standard deviation, I'm sorry. The first thing that you need to do is in your calculator, press stat and then enter to put the data in. And this time you're only going to enter the numbers into L1. When we were doing regression, we used both L1 and L2. And again, this time we're only going to use L1. So once you have typed all the numbers in, and I'm just going to write data. So you're going to enter your data, and then you're going to press stat again. And then you're going to right arrow to calc. And then you want number 1, or just press enter for the one variable statistics, and then you want to down arrow twice and then calculate. And remember that that gives you a list that has more things than you will actually use, but the one that you're looking for says in the calc, and I'm writing this off to the side, your calculator says X bar. But remember that the SOL doesn't use X bar, but uses the term, or the symbol mu, which is the thing that looks like it has a U with the tail in the front and the back. And so that's the thing that stands for the mean. You need to really remember that symbol in your calculator. So anyway, when you have typed all that data into your calculator, it should tell you that the mean, or mu, is equal to 2.375. And the standard deviation is the Greek letter sigma, and it looks like a cross between a cursive S and a O. And your calculator should tell you that that's 4.55. And when you scroll down, it also tells you that the median, which just says MED, the median is equal to 1.5. So there's the mean, median, and the standard deviation. And once again, just to be sure that we're all on the same page, remember that the symbol for the mean is mu, and the symbol for the standard deviation is this sigma. The next question using the same data is that you're asked to find the z-score for a score of 0. And remember that you will be given the formula for a z-score, which is that the z-score is equal to whatever element of the data minus the mean divided by the standard deviation. And so in this case, the element of data that we're talking about is this x equals 0, or x sub I equals 0. So our z-score is going to equal 0 minus, and then the mean is 2.375, and the standard deviation is 4.55. And when you put this in your calculator, type the whole thing in as a fraction and not as a division problem, because your calculator would do the division first and then subtract it from 0, and it would do the order of operations wrong unless you use parentheses in the correct way. But because your calculator will do fractions, make sure that you type that in as a fraction. So anyway, the z-score for this data element should give you negative 0.52, which means that the data element 0 is approximately a half of a standard deviation below the mean. So you're going to do the same process for number 2, and what I would recommend is that you pause the video, you clear your calculator and start fresh and type all the data in and do the computations for that and for the z-score in part B, and then turn on the video again and check your answers. So this is what you should have gotten. Mean is 14.14, the standard deviation is 6.51, the median is 11, and the z-score for the data element 16 is 0.29. Now, take a minute, pause the video, read this next problem. And the keywords really are the ones that I highlighted or I bolded here. Greater consistency in the scores, and the consistency really is about the standard deviation. And remember that standard deviation measures basically the average distance that each data element is from the mean. And so how far away is each thing from the mean? And so if the data is more spread out, then it's going to have less consistency. If you have, in this case, you've got scores on an examination, if you've got the scores really spread out all over the place, then they're going to have a larger standard deviation. And if the scores are all much closer to the average score, then you're going to have a much lower standard deviation. And so in this problem, it says here that the Adams School has a mean of 875, which really doesn't contribute to the problem much, but the standard deviation, that's the important piece of information that we need here, is 12. And for the Boswell School, they're saying that the mean is 855 and the standard deviation is 20. And since the standard deviation for the Adams School is lower, it's a lower number, then that indicates a greater consistency in the score, because more of the scores are closer to the mean than at the Boswell School. And so in order to explain how you arrived at your answer, you'll want to say something like maybe the Adams School had greater consistency in their scores. Because their standard deviation or the spread is smaller. In other words, the scores are closer together. So take a minute and read number 4, which says that Phyllis got a certain score on a test and that score is 1 standard deviation above the mean, and the standard deviation is 6. And so basically, you know that Phyllis's score, or that particular data item, is 84, and you also know that the standard deviation is 6. But the other thing is that she scored 1 standard deviation above the mean. So you actually know that Phyllis's z-score is 1. It's positive because it's above the mean. And remember that the z-score measures how many standard deviations above or below the mean is the score that you're talking about. So the question is asking what's the average score on that test, and you could probably just use your intuition to find that algebraically, but if you're not sure, use the z-score formula, which says that it's the data element value minus the mean divided by the standard deviation. In this case, the z-score is 1. You're just going to substitute. You're essentially substituting what you know. So I know that the z-score is 1. I know that Phyllis's score is 84. I don't know what the average is. And I do know that the standard deviation is equal to 6. And so I'm solving for mu. And basically I would, if I were solving this equation, I would multiply both sides by 6 so that the 6's here cancel. And then I have 6 is equal to 84 minus mu. And then if you add mu to both sides, subtract 6, what you'll get is that mu is equal to 78. And so the class average is 78, and Phyllis scored 84, which is 6 points above the class average. Take a minute and read number 5 to yourself. A normal distribution says that approximately 68% of the scores, or whatever the data is, fall within 1 standard deviation of the mean. And it's important that we use the word normal here, because if it's not a normal distribution, it might still have statistics and it will still have a mean and a standard deviation. But the thing that you can't say is that 68% or approximately 2/3 of the data fall within that 1 standard deviation of the mean. So what I would do here is I would go ahead and draw that normal curve. And remember that your mean is in the middle, and that we're going to kind of draw vertical lines for +1 standard deviation and -1 standard deviation. And that this portion of the graph, -1 standard deviation to +1 standard deviation, is the 68%. So from here to here, that is 68% of the data. And they tell us, this problem tells us that those scores fall between 72 and 86. And so it's just asking what the standard deviation is. And so the first thing that it will help me is if I compute the mean. Well, that's just the average between the 72 and the 86. So if I compute that and say, okay, well, 72 plus 86 divided by 2, I should get 79. So this value is going to be 79. And the difference between 72 and 79 is 7. And the difference between 79 and 86 is 7. And therefore the standard deviation is going to be 7. Again, it's important that you look for this word normal or normally distributed before you start working out a problem, so that you know what the distribution is. If it doesn't specify that it's a normal distribution, then we can't assume that the percentages that you've memorized, hint, you have to memorize the percentages, that those percentages are applicable. So anyway, the mean here is 68, and move my papers around a little bit here. So we're told that the mean is 68 and the standard deviation is 4.5. And it's looking for the number of scores or the percent of scores that fall between 59 to 77. So the first thing that I'm going to do when it's talking about a normal distribution and I'm given this information of the mean and the standard deviation is that I'm going to draw a picture. So I'm going to draw my normal curve and I'm going to label at least 2 standard deviations in each direction, but I might end up labeling 3 if I think that I'm going to need that many numbers. And so here I have mu and plus 1 standard deviation, plus 2 standard deviations, plus 3 standard deviations, minus 1, minus 2, and minus 3. It's basically just like a number line. And then here we know that the values of the standard deviations are, we know that the mean is 68 and standard deviation is 4.5. So just take your calculator and add and subtract 4.5. So for 1 standard deviation, you should get 72.5, and for plus 2 standard deviations, you should get 77. And for minus 1 standard deviation, you should get 63.5. And minus 2 standard deviations, you should get 59. And that looks to me like those numbers are going to be sufficient to find the area from 59 to 77. Because here's 59 and here's 77. And so I'm not going to need that 3rd standard deviation in this problem. And so the percentage of this much of the graph from here to here, that's going to be your 95.4%. So from there to there is 95.4%. All right, so for this next problem, we're told that the mean is equal to 56 and the standard deviation is equal to 5. And it's asking this time for the opposite of what the previous problem asked. It's asking what's the interval where 95.4% of the population falls. And so here, again, I'm going to draw my normal distribution. And because I already know it's 95.4, I'm only going to need plus and minus 1 standard deviation, 2 standard deviations. I don't need the 3 because, again, in this case, I already know that plus and minus 2 standard deviations is going to be that 95.4%. From here to here is 95.4%. And so if it gives me the information that the mean is 56 and that the standard deviation is 5, then this is going to be 61 and 66, and this is going to be 51 and 46. And so my answers then are going to be from 46 to 66. So in order to work out this problem, The first thing that you'll need to do is take the data, which are the test scores for these 20 students, and enter that into your calculator, just like we did on the previous page, in Stat Edit and then in the L1 list, and use the Stat Calc menu in your calculator in order to compute the mean and the standard deviation of this data. So pause the video and go ahead and do that. And you should have found that the mean is equal to 79.7 and that the standard deviation is equal to 8.71. And then it asks if or what percent of the students scored within one standard deviation of the mean. And so basically what you want to do is to compute the mean plus one standard deviation and the mean minus one standard deviation. And you're going to use those numbers, the 79.7 plus 8.71 and 79.7 minus 8.71. And you should get, for the plus standard deviation, or the mean plus one standard deviation, you should get 88.41. And for the mean minus one standard deviation, you should get 70.99. And so you want to look for, you're going to go back up to the data set, and you want to know the percent of students who scored in that range. And so you're going to look for every score that occurs between 88.41 and 70.99. So I'm going to go ahead and circle them, and that would be, well, let's see, 70, not 70.99 is too low. 60 is too low. 75 is in that range. 68 is too low. 85 is in the range. 86 is in the range. 78 is in the range. 72 and 82 and 88 just barely. And there's another 88. And then 73 does, yes, and 74 does. 79 does, 86 does, 82 does, 90 does not, 92 does not, 93 does not, and 73 does fall in that range. And so I'm going to count then how many do fall in the range. And so there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 14 out of 20 scores fall in this range. And so that's going to be 70%. And the question really is, do the results approximate a normal distribution? And remember that normal, to call something a normal distribution, you have to have about 2/3 of the data in that range between the mean plus one standard deviation and the mean minus one standard deviation. And 70% is approximately 66%. And so I'm going to answer yes to this question. Now here in number 9, you're told that it is a normal distribution. You're given the mean is 150,000 and the standard deviation is 25,000. And that a house had a sale price of 175,000. The real estate agent tells the customer that most houses had selling prices between 125,000 and 175,000. So essentially, because it's normal, we can draw a normal curve for this. And essentially what we're saying here, and I'm going to not write all the zeros out to save space, but if the mean of the home prices is 150,000, maybe I will write the zeros, there we go, and the standard deviation is 25,000, that means that the mean plus 1, that's the mean, and the mean plus 1 standard deviation is going to be 175,000. And the mean minus 1 standard deviation is going to be 125,000. And remember that, and those are the numbers here that the real estate agent quoted. And remember that this portion of the normal curve from plus 1 standard deviation to minus 1 standard deviation is right here approximately 68%. And that's more than half. Therefore, let's say that more than half of the homes fall within 1 standard deviation of the mean. So here in number 10, your mean is given as 42, and your standard deviation is given as 12.1. And I would go ahead and draw and label a normal curve. And grab your calculator and add and subtract. So 42 there in the middle, 54.1 and 66.2, and minus 1 is 29.9. I said 9, I wrote something else. Hopefully you won't see that. 29.9 and 17.8 here. And it's asking which of those scores listed would happen less than 5% of the time. And we know that at the ends of the curve, each of those ends from here to infinity and from here to negative infinity, that's about 2.3% or 2.5%. And so that means that anything above 66.2 or below 17.8 would fit what we're trying to say here. Well, 25 is not above 17.8 or not below 17.8. Neither is 32. 60 is not above 66.2, but 67 would be maybe about there. And so 67 is going to be our answer. So this problem uses the word average, but that's the same as the mean. And it tells you that the standard deviation is 0.7 and that it's a normal distribution. And so I would make those notes to myself that the mean is 2.8 and that the standard deviation is 0.7. And the question asks what's the probability that it'll take him between 2 and 3 hours on his birthday to complete his homework. And so because if you were to add and subtract the standard deviation 0.7 from the 2.8, you get like 2.1 and 3.5, and those numbers, the 2 and the 3 here, don't represent a whole plus or minus 1 or 2 standard deviations. And so in this case, we want to use the calculator function that will compute these probabilities for you. So remember that is, you go to your calculator and you press second and then vars. And when you do that, you're going to look for number 2, which is normal CDF. And then it's going to ask you for a lower and upper, the mean, and the standard deviation. And so your lower and upper are going to be the 2 and the 3. Your mean is going to be that 2.8, and your standard deviation is going to be the 0.7. And then you want to go down to paste and click on that. And then you want to press enter again. And your calculator tells you 0.485 and so on. And remember that you want to give your answer here as a percent. Well, you can give it as a decimal. So your answer here can be either, let me change colors, 0.49 or 49%. And I'll accept either of those answers. So I'll take either 0.49 or 49% as your answer. So in this problem, it's just asking you to look at the normal curve given here and look for the mean and the standard deviation of the data. And remember that the mean is always the middle of the graph. And so in this case, the mean is going to equal 63 inches. And then the standard deviation, remember, is the distance between the units. From here to here is the standard deviation, and that's why they're all the same width. And so to find the standard deviation, all I would do is say 67 minus 63, and that's going to equal 4. And so the standard deviation is equal to 4. So in number 13, you want to compare these quantities. And which quantities are we talking about? We're talking about the data value here. And so let me do column A with purple. So it says that the mean is 15 and the standard deviation is 4.3. And this data value is 3 standard deviations above the mean. So really you're thinking here mean plus 3 standard deviations. The mean is 15 plus 3 times the standard deviation, which is 4.3, and you can plug that into your calculator. And you should get 27.9. And I'm going to do that same process then with column B. It says in column B that our mean is given as 35 and the standard deviation is 2.9, and that the data item is 2 standard deviations below the mean. And so that you're talking about mean minus 2 times the standard deviation. And so that's going to be 35 minus 2 times 2.9. When you plug all that into your calculator, you should get 29.2. And in this case, the quantity in column A is definitely not greater. The quantity in column B is greater. The two quantities are not equal, and the relationship, yes, it can be determined. So your answer there is letter B. So here we have another normal distribution problem, and it tells us that the mean is 11 and the standard deviation is 1.5. And if you are looking to see if the probability that a shoe size is greater than or equal to 1 standard deviation above the mean, that would mean that we're talking about 11 plus 1 times 1.5, which is 12.5. And I would use the second VAR's normal CDF function in the calculator. Remember though that in this case, 12.5 is your lower bound. So when you're typing this in, lower is 12.5. What you're going to do for the upper bound, because it says greater than, it doesn't say that there's any end to it, so it's going to go to infinity. And because your calculator doesn't have infinity, you just type a bunch of 9s. And the calculator gets tricked into thinking that that's infinity. And when you do that, you should get that the probability is 0.16 or 16%. And in the other problem, you want to see what the probability is that the shoe size is less than 1.5 standard deviation. So 1.5 times sigma would be 11 minus 1.5 times 1.5. And so that would be 8.75. And so you want the probability that x is less than or equal to 8.75. And again, you're going to need to trick the calculator. And so for your lower bound, you can't type negative infinity. And so you're going to have to type negative 99999999999 until you get tired of 9s. And your upper bound is going to be 8.75. And when you've done all of that, you should get your answer is 0.067 or 6.7%. Now for number 15, you should notice that we're talking about a normal distribution. Remember that you always want to look for normal or normal distribution or normally distributed normal curve, something to that effect. They give you your mean, they give you the standard deviation, and they say that the regulations state that the balls need to be between 8.5 and 15.6. And you should also recognize this number, the 95.4, and that represents the plus and minus 2 standard deviations. then the area under the graph, or the probability between the mean plus 2 standard deviations and the mean minus 2 standard deviations. And so I kind of like to make a little note to myself that the mean is 12.7 and the standard deviation given is 2.3. And then I'm going to make a real quick normal curve here. And then I'm going to label +1 and -1 standard deviation, +2 and -2 standard deviations. And if the mean is 12.7, then +1 standard deviation is going to be 15, and +2 standard deviations is going to be 17.3. And -1 standard deviation is going to be 10.4, and -2 standard deviations is going to be 8.1. And so we're asking, we're looking at this for 8.5 and 15.6. And 8.5 falls right about here, and the 15.6 falls right about here. And so what we're looking at here is that the actual soccer balls that they tested, 95% of them were between 8.1 and 17.3. And it's asking if 95% fell between the regulation of 8.5 and 15.6. And so essentially these balls that were in this space right here and in this space right here were outside of the regulation. And so if you wanted to compute a probability with your calculator using the normal CDF, you could look for the probability that X is between 8.5 and 15.6, normal CDF, and this would be your lower and this would be your upper, and you would find something approximately 86% of the balls were regulation, therefore 95% no, only 86% of the balls fell within the regulation range. Now for number 16, we're given the mean is 500, standard deviation is 40. And if it's asking about numbers between 423 and 560, it should be clear to you that those aren't exact plus or minus 1 or 2 or 3 standard deviations. And so I would just use the normal CDF on your calculator. So again, the mean is 500 and the standard deviation is 40. And so in my calculator, I'm going to go ahead and type these numbers as your lower and upper. So the lower would be 423 and the upper would be 560. And that's with the normal CDF. Remember that that's normal CDF. Second vars. I guess I'm doing this all backwards, but so you press second vars and then it's number 2 and then the normal CDF, and you want to give the lower is 423, upper 460, the mean is 500, and the standard deviation is 40. And when you do that, the probability that the number will be between 423 and 500, you should get 91% or 0.91. But that doesn't answer the question. Make sure that you see that the question says how many of the 789 students. And so what you need to do for this problem then is multiply that 0.91 times the 789 students, or 91% times the 789 students, and you should see that 718 students got a score between 423 and 560. So in this problem, you're not given the standard deviation, you're asked to compute it, but they give you enough other information. So here they tell you, and again, make sure that you see that it's normally distributed. Did I point that out on the previous problem? Normal distribution. That it's normally distributed, and that the mean is 66 inches. And I always like to make a note of the mean. It's 66 inches. And then it gives you this magic 95% number between 63 and 69. So that means that the 63 and the 69 are the plus and minus 2 standard deviations. So if I were going to draw my normal curve for this data here, you're given the 66 as the mean, you're given 63 as minus 2 standard deviations, and 69 as plus 2 standard deviations. And there's any number of ways that you can compute the two missing values. I would personally just take the average of 63 and 66, and if you add those together and divide by 2, you should get 1.5, and that should give you the 64.5 here. And then that would be the same if you did it here, and that would give you the 67.5 here. But that 1.5 is your standard deviation, so your sigma equals 1.5. And remember that we did that because from, I guess I didn't point that out, that from the minus 2 standard deviations to the plus 2 standard deviations, that area under the graph there is 95%. So from here to here, that's 95% or 95.4%. Now, this problem uses the word standard normal curve, and that means that the mean is 0 and the standard deviation is 1. And so you're literally going to go second VARS and then number 2 for normal CDF. And you're looking for the probability that Z is between negative 0.58 and 2.05. And when you do your second VARS and normal CDF, this is going to be your lower, and this is going to be your upper. And once you've pressed all those buttons, you should get 0.699. So we've got a normal distribution here for number 19. The mean is 23. The standard deviation is 2.5. and you're asked to find the portion or the fraction or the percent of the population that is between the numbers 18 and 28. So this is another one that I'm going to use second vars to normal CDF. And then you're going to find that this is your lower and your upper bounds, your mean and your standard deviation, and it should give you that the probability is equal to 95.4%. Or I guess I should have put 0.954 and so on. Interesting. I just now did that problem without looking at my answer key, and in my answer key I had drawn out the normal curve, and if you had recognized that 23 plus and minus 2.5 twice would be 18 and 28, then you could have just done your curve and drawn out the numbers, and you would have had 23 here, 25.5 here, and 28 here. In the other direction, 20.5 here and 18 here. And so you would see that that's the part of the curve that's from here to here that's 95%. So either way. So I'm just going to make a little list of the information I have about each of my classes. So here, the period 2 class has a mean of 81 and a standard deviation of 3. And my period 3 class has an average of 81 also, and a standard deviation of 12.3. Now, first of all, it doesn't say anywhere that it's a normal curve. You don't have to draw the normal curve, and it wouldn't fit those percentages. But the problem's not even asking you that. It just asks you to talk about what the information is. And since the class average is the same for both classes, then that's not a very interesting data point. But what I would look at is how very different the standard deviations are. And remember that standard deviation measures spread. So that would mean that the grades in the period 3 class are much, much, much more spread out than the grades in the period 2 class. Or you could say alternately that the period 2 class grades were much closer together. So one or the other, let's say here, the period 2 grades are much closer together. They're the period 3 grades. Are much more spread out. So the first thing that you want to kind of eyeball here is that they're normally distributed, and so if you need to, you can draw a normal curve. Actually, as you read this problem, the normal part doesn't affect the problem, but what you really want to see is that the data for males age 16 is a mean of 35 and a standard deviation of 6, and the data for females 16 years old is a mean of 32 with a standard deviation of 8. So that's the first piece of information that you want to look at, and then I might like make a little list over here like I did in the previous problem and just say, okay, the data for males has an average of 35, standard deviation of 6, and then for females the average is 32 with a standard deviation of 8. And so then they give you this information about this family, and the family has both a son and a daughter, and the son did 42 curl-ups and the daughter did 42 curl-ups, both of them when they were 16 years old. And although they were both above average, you can't really compare the number of curl-ups that they did because the data groups are different, and you can't compare Larry directly to the females or Georgette directly to the males. So you want to kind of compute the z-scores, and a z-score is how you compare something that is from two different data types. So you want to say here that the value of the data element that you're looking at for Larry is 42, and the one for Georgette is also 42. And then what I'm going to do is I'm going to compute each of their z-scores. So here for Larry, his z-score is going to be his score minus the mean divided by 6, and just throw that in your calculator and you should get that he had a z-score of 1.17. So he's a little more than 1 standard deviation above the mean. And then Georgette, to compute her z-score, you would do 42 minus that girl's mean, that's 32, divided by 8, and her standard deviation is 1.25. And so her performance is more impressive because her z-score is higher above the mean, or if you count the number of standard deviations, she's higher beyond the mean than he was. So your answer is Georgette. Now, for all of the parts of number 22, you again want to use the second vars, and then number 2 for normal CDF. And for A, this is going to be your lower, and this is going to be your upper. And I'm going to give you the lower and the upper for each, and then I'm going to have you pause it and try each. So for letter B, your lower is going to be the negative infinity trick, right? Negative 9999999, because Z is all the numbers less than 0.74, and then the 0.74 is going to be your upper. And then part C is going to be the other way around. Z is all the numbers above the negative 1.13, so the negative 1.13 is going to be your lower, and then your upper is going to be the positive 99999999999 trick of making the calculator think that you're typing an infinity when you don't have an infinity to type. So go ahead and type those in, pause the video, and come back in a minute. And you should have 0.82 for the first one. You should have 0.77 for the second, and then you should have 0.87 for the third. So in number 23, Notice that the snowfall is normally distributed. Can you tell we manufactured this problem because the snowfall at this point is probably skewed due to climate change? Just saying. So the first thing that I would do is take all of this data and I would, sorry, changing my pen colors. I would take all this data here and I would type it into stat edit in L1. So go ahead and put all of that into L1. And then to compute the mean and the standard deviation, you're going to do stat and then calc, and you want number 1 for one variable statistics. And you should get that the mean is 100.51 and the standard deviation is 29.06. And then you're going to use those numbers that you just computed and label the normal curve that you see here. So remember that your middle value is always your average. And then I'm going to do +1, 2, 3 standard deviations. And then I'm going to do -1, -2, -3 standard deviations. And really I should be drawing these a little bit more evenly, but I'm not, sorry. And when you run these through your calculator, you should have 13.33, 42.39, and 71.45. The mean we said is 100.51. +1 is 129.57. +2 is 158.63. And +3 should be 187.69. And then the last question on this page asks you to show that region under the normal curve where approximately 68.2% of the heights are located. And remember that that's between -1 standard deviation and +1 standard deviation. So for 24, 25, and 26, first of all, notice that all three problems say normally distributed, and normally distributed. So they're all about normal distributions, and that's why I have given you those little graphs for each of them. And then also notice that they have that set number of the percentage that you should recognize in each of them. So we're just dealing with the straight normal curve. You don't need to do your second vars. Those percentages should just be your plus and minus standard deviations. So for example, here in number 24, you're given the mean and the standard deviation is 78 and 6.3. And so if this is your mean, is 78. The 68.2 is just plus 1 standard deviation and minus 1 standard deviation. And so if you add and subtract the 6.3, you should get 71.7 and 84.3. And so that's just your answer then, is between 71.7 and 84.3. And so then I have no idea when I wrote this problem or the movie Frightening, and maybe I just made it up, but because I don't watch horror movies. I'd be more likely to watch a movie called Flowers and Pretty Things than Frightening. Ooh. Anyway, so they're saying that there's a normal distribution to the ages of the viewers that are attending this movie, and 95.4% of the ages is between the age of 14 and the age of 45. Good, because I'm 98 or something, and so I don't fit in that group. So you're going to find the mean and the standard deviation of the data. They don't give you those things. So remember that the 95.4 number is the one that is related to plus and minus 2 standard deviations. And so here you're saying that minus 2 standard deviations is 14-year-olds, and that plus 2 standard deviations is the 45-year-olds. And so here's your mu, plus 1 standard deviation, minus 1 standard deviation. And what I would do, there's a number of different ways that you could compute this, but I would take the, excuse me, I would take the average of the 14 and 45. So I would say, okay, 14 plus 45 divided by 2, that's going to give you the middle, right? So halfway between 14 and 45, when you do that in your calculator, you should get 29.5. So that's going to be your average, or your mu, or the mean, 29.5. And then I would do that whole process again, but this time with just the 14 and the 29.5, and that'll give you the minus 1 standard deviation. So I would say, okay, 14 plus 29.5 divided by 2, and the number halfway between 14 and 29.5 is 21.75. And if you wanted to, you could do these two numbers, exactly the same thing, 29.5 plus 45 divided by 2, and that would give you 37.25. But the problem doesn't ask you specifically for these two numbers. It asks you for the standard deviation. And so the standard deviation would just be to subtract any two of these numbers that are side by side. So you could just say, okay, 45 minus 37.25, that gives you the standard deviation, which you should get is 7.75. And so over here, the mean we said is 29.5, and the standard deviation we said is 7.75. And the next problem is fairly similar. You might want to pause the video and try it on your own. It gives you the same 95.4, which means that you want the data that falls between plus and minus 2 standard deviations. And then you just want to divide it into 4 pieces until you find the mean and standard deviation. So in number 27, this is another problem about a normal distribution, and you're given the information that the mean is 7.2 and the standard deviation is 1.4. So the mean is 7.2 and the standard deviation is 1.4. And it's basically looking for the giraffes with the long necks, because it asks for necks that are more than 2 standard deviations above the mean. And so you really only care about mu plus 1 standard deviation plus 2 standard deviations. And this right here, above that, is 2.3%. And so I would actually not even compute those numbers. I want everything that's right in here, this little sliver here. I wouldn't compute the numbers. I would probably just say, okay, if we're looking for 2.3% of 2,500 giraffes, I would do that in my calculator just multiplying the 2.3%. Remember, you're going to change a percent to 0.023 times 2,500. And that should give you 57.5. And hopefully we don't have a half a giraffe, so you could say something like 57 or 58 giraffes. And my apologies if that problem sounded chopped up in the video. I was stopping and starting and needed to go back and re-record something. So hopefully that made sense. You're just looking for 2.3%, which is the percentage that you memorized for the greater than plus 2 standard deviations, and you've got a population of 2,500, so you multiply the 2.3% times the 2,300, and you don't really need to compute plus or minus standard deviations from the mean. Now for this problem at the bottom of the page, you should notice that, again, it's giving you a normal distribution, and the mean is 97.2, the standard deviation is 6.1. Remember that I like to make a note of that to myself. So the mean is 97.2 and the standard deviation is 6.1. And it's asking about all the numbers that fall between 1 and 2 standard deviations, either above or below the mean. I would draw the curve and label. And so if this is 97.2, I think I'm going to have to squish some stuff. This is 85. This is 91.1. This is 103.3. And this one is 109.4. And we're specifically looking for any of the values that fall between 1 and 2 below the mean. That would be this one that I'm highlighting in pink right now. And 1 and 2 above the mean. And so you're basically looking for numbers that fall between 85 and 91 and 103 and 109 with those decimals. Sorry, I didn't want to confuse you. And so 105 falls in that range, so I'm going to circle 105. And then 92 is over here somewhere, and 98 is over here somewhere, and so is 96 is in there somewhere, and 111 is over here somewhere, and 35 is like over here somewhere. And wait, 107, well, 107 is in this space as well, 100 would be over here somewhere, and 129 would also be over here somewhere. And so just the 105 and the 107 fit that description. Okay, so now you want to switch your math brain over to the probability side, get away from the normal curves and means and medians and standard deviations, and start thinking about combinations and permutations, and how to count things that have multiple ways of doing something. And let's start with the fact that this restaurant has 4 appetizers, 3 soups, 7 entrees, and 5 desserts. And Megan decides to order an appetizer or a soup, not both. So the appetizers and the soups, there's 4 appetizers and 3 soups. So there's 7 things that she can choose from. She certainly doesn't want both an appetizer and a soup, because you can only eat so many jalapeno poppers and then eat cream of broccoli soup or something. Who would eat jalapeno poppers and follow it with cream broccoli soup? Anyway, there's a combination of 4 appetizers and 3 soups, and so there's 7 things there that she's going to choose from. And then she's going to have 1 entree. Well, there's let me switch colors here. So she's going to choose 1 entree, and there's 7 choices there that she can choose from. And then she's going to have 2 different desserts. And so for her desserts, there's 5 possible dessert choices, but she's going to choose 2 of the 5, but she wants them to be different. And so in your calculator, you can just multiply the 7 starters times the 7 entrees, and then times the combination, 5 choose 2. And remember, to get the combination, first you want to type into your calculator the number that comes first in the problem. So that if you're trying to type in 5 choose 2, you want to type the 5 first. So type the 5, and then click math, and then left arrow to PRB, and it is choice number 3. Oh, I just made it graph something. So choice number 3. And what'll happen then is that your calculator is going to say 5, and then it's going to say NCR like this. And then you want to type the 2 in your calculator. And when you do that, hang on a second. The calculator, you can type this whole thing into the calculator, the entire thing, including the 7s. And when you do that, you should get 490. If you were to only just do the 5 choose 2, that would give you 10, and then you would multiply by the 7 times the 7. For number 30, notice that you've got 3 body styles and 2 different engines, 2 different transmissions, and 6 colors. And so this car dealer wants to be sure that there are one of every possible combination, so that, for example, that they might have a sports coupe that has, I don't know what 2 different kinds of engines are, you maybe know that, I don't, with a manual transmission that comes in yellow or something, so that they've got every possible different combination. And so you want to actually just multiply those numbers. So 3 body styles times 2 engines times 2 transmissions times 6 colors, and you should get 72. And then in number 31, it's asking for 3-member teams, but it's not assigning the members of the team to certain jobs. And so it's just 3 people, and they're all doing the same job, and therefore you're doing, from a group of 7, you're choosing 3. And there are, again, using the same calculator technique that we used for number 29, 7 choose 3 will compute to 35. And again, in number 32, you've got 5 people, and you're looking for committees of 4, but it doesn't give each one of the 4 people a task. It just asks for committees of 4 from the 5 people. And so you've got 5, and you're going to choose a committee of 4, and there's 5 ways you can do that. So we have a soccer team that has 23 players, and the coach is going to choose 11 players to start the game. And you know how little kids' games are. They just put the kids on the field, and everybody runs all over the place and tries to kick the ball. And a lot of times with the little kids, they don't even keep score or have championships or anything. They just have the kids run around the field kicking the ball. So anyway, if you have this soccer team, and it specifically says that it doesn't matter what player plays which position. So they're not really putting the kids in positions yet. You want 23 choose 11, and that's going to give you this massive number of 1,352,078 ways that the coach can choose 11 players from 23 that are on the team. So here I have 25 books, and I'm choosing to read 8 books this summer. I probably don't have time to read more. Hint, I probably won't even read 8 books this summer. I'm going to try, but we'll see. The books I have in my pile are pretty long. But here's the key sentence, and you really want to pay attention to this. The fact that I am going to rank, and there's the important word there, I'm going to rank each book in order of my preference. That means that there's an order, and so this is now going to be a permutation. And I want you to compare here. This one here was a combination, and this one here was a combination, and this one here was a combination, and this one here was a combination. And what I want you to do is read those 4 problems that I just obliterated with my red pen. And I want you to think about how order does not matter for those 4 problems, 29, 31, 32, 33. But in 34, this is a permutation, and how I wrote the problem means that the order matters. And so to type this into my calculator, 25 permutations of things taken 8 at a time, I'm going to type the 25 first, and then I'm going to press math, and I'm going to left arrow to PRB. And this time, the NPR is number 2. And then then it takes you back to your home screen, and you can type the 8 and then press enter, and that gives you some crazy massive number with an E in it, and that means 10 to the 10th power. So I'm not going to put any crazy thing on your test like that, but that's 4.36 times 10 to the 10th power. And just make sure you understand the difference between a situation where order matters and a situation where order does not matter. So this is a license plate problem, and you want to make note of the fact that you've got 5 characters. So there's going to be 1, 2, 3, 4, 5. And the first 3 are the numbers 0 through 9, and the last 2 are a letter A to Z. And 0 cannot be the first digit. So instead of 10, there's only 9 numbers you can put in the first spot. And then the letters cannot be repeated, but the numbers can. So you've got 3 that are numbers. And you're only leaving out 1 number from the mix in the first place. So this one you can't have a 0. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 digits or 9 numbers you can put there. But the other 2, you can include 0. And so here you've got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 10 that you can put there. And then those last 2 are going to be letters. And the letters can't be repeated. So you've got 26 letters to choose from, but once you've put the letter into this spot right here, you can't use it again. And so there's only 25 letters that can go in that next spot. And you're going to take all those numbers, 9 times 10 times 10 times 26 times 25. And when you multiply them all out, you should get 585,000 possible license plates that can be used in Alaska. This problem is straight multiplication. So there's 8 different places somebody can come into a stadium, and 6 places where you can take the escalators up to the seating areas. You can come in any entrance and go to any escalator. And so there's 8 times 6, which is 48 different routes to get to your seat from your car. In number 37, it doesn't say anything about order. And so this is going to be a combination. And again, number 38 doesn't say anything about order, so that's also going to be a combination. And for 39 and 40, you're just going to type those into your calculator using the math left arrow and then PRB. And permutations is number 2 and combinations is number 3. And remember that you want to type that number that's to the left first, and then type math PRB and the combination or permutations. And so for number 41, that's 39. I dropped some problems somewhere or misnumbered something, I think. Anyway, so for 39, the answer is 35, and for 42, your answer should be 3,628,800.